Hello everyone, I'm Chaitanya and I'm from Team Arthur. I'm going to give a presentation on 2D model using freeform NURBS curves and 3D model using a modeling tool. Mm, My teammates are Babar and Farhat. 2D model of a signature using a freeform NURBS curve. We model a 2D model of our own signatures using freeform NURBS curves. For this, we have used modeling tool Blender version 2.9. The steps to create 2D model of a signature using NURBS curve are the following. First, you sign your name as you usually do on a paper and scan the signature or take a picture of it. Now, open Blender and choose the view as orthographic front. Now import the image of the signature into the Blender by clicking on Shift plus A, and you get the option to select an image, and in that you choose reference and choose the image and upload. Now press Shift A and choose curve, and inside that choose NURBS curves and select the edit mode. Once you are in edit mode, you'll be able to control the control points size of the curve. So start with the one side of the signature and trace along the signature by adjusting the control points and adding more control points and by fine tuning them. Now change back to object mode and hide the control points and image to look at the signature that we created using the NURBS curve. Here is a signature of Babar, which he did it on paper. Then we traced it, put it into Blender, and then we traced the control points along the signature of signature. And after it's completely traced, we simply hide the control points and the image and turn back into the object mode. And the third picture is the NURBS curve, which we get, which we design alongside the signature. This is my signature, and uh, the third image is the freeform signature we designed using the freeform nerve scale. And this is signature of Farhat, and the first image is image of his signature, and the second image is control points traced along the signature, and the third one is the model which we designed by tracing the control points along the signature. And here is our company. Our company name is 3D Roadway. Our company management approach is a democratic approach, and our company follows a participatory approach which requires a collaboration between leaders and lower hierarchy members of the company. The main aim of our company is to build products like building material tools, furniture products, etc. And here is the logo of our brand, 3D Roadway. So, as part of our 3D model, we have designed a nut and a bolt, which is one of the our company product. Stages in modeling nut and bolt. Initially, we start with a cylinder. For this, I open Blender and choose a cylinder and create a cylinder initially. Now I have adjusted the vertices of the cylinder, and to create a hole in the top of the nut, I have chosen another cylinder and given some particular vertices 6 to and placed it on top of the initial cylinder. And finally I created the top of the uh, nut with a hole by applying a boolean of first cylinder and the second cylinder. Next, I created the bottom of the nut by creating another cylinder, and I made the surface of the cylinder to smooth by using auto smooth and smooth. Then I created loop cuts to the bottom of the nut from where I wanted the nut bevels to be. Then I created bevels on the nut as you can see on the first image. Then I created bolt using another cylinder, and I have created the bevels inside the bolt by bullioning the nut onto the bolt. After that, I have created the surface in such a way that it looks realistic, so I applied a metallic steel surface look to the nut and bolt. And finally, I've smoothened the edges of the nut and bolt so that they look more realistic to the real world model. And here is the final model of our nut and bolt. The second 3D model which we created is a chair and a table. For this, we used Autodesk Maya. Initially, we used a polygon square surface and adjusted its height width for the surface of the table. We can adjust the dimensions using the mouse dragging or by entering the values in the table which we can see here. Next, we bevel the edges of the table surface to make the surface smooth. Elevate the surface of the table, use another program polygon cube to create the leg of the table. Now adjust the bottom of the table legs by going to the object mode and using the scale tool. Now we duplicate the legs by using Ctrl D and changing the value of scale X, Y or Z. Now for designing the chair, we initially started with the chair legs. We used polygon cube for this, adjust the height and depth according to our requirements, and align both the legs to the origin. To tell the back leg, we have the insert edge loop function with the help of a model. To increase the height of the back leg, we have the extrude function at top surface of the back leg. Then we created the remaining element of the chair by using a polygon cube. We adjusted the height and width of the new polygon according to the requirements. And we used bevel element to make all the edges smoother. And for the chair seating frame, we have used a polygon cube and adjusted it according to our requirements. To change the radius of the seating frame from sides, you need to go to the vertex mode. Then change the values of soft selection mode of move tool, and we can adjust the radius of the sides. And here is the final model of our chair and table. For the nut and bolt, initially I created a cylinder and I changed the vertices, and I created a hole on the top of the nut by booleaning, doing the boolean of one cylinder inside this cylinder so that a hole is formed. For the body of the nut, I have created another cylinder and made the surface smooth by using shade smooth and auto smooth. After that, I have created loop cuts to the bottom of the cylinder and created bevels by dragging the loop cuts so that the bevels are created as on the real nut. Next, I created the bolt by using another cylinder and I placed it on the bolt cylinder in the place where the bubbles are present, and then I boolean the values of boolean the initial cylinder onto the bolt by using this modifier, add modifier and boolean. By doing so, I was able to create bevels on the inside edge of the nut, so it looks in this way. After that, I've applied material properties to the nut and bolt by going here, and I have given steel as a material property to the nut and bolt, and we can adjust the metallic level and roughness from here. After applying that, if I select this without shading, we'll get this in a metallic view. So at the end, I applied smoothing to the edges of the nut and bolt so that it looks more realistic to the real world bolt and nut. So this is how we created nut and bolt using cylinders, loop sections, bevels, and smoothing of surfaces and metallic properties which are inside, which we can do from the blender.
Good evening everyone, my name is Babar Ghafoor. The model I'm going to show is a 3D model of a chair and a table. We built it in Autodesk Maya. So first of all, we used a polygon cube and aligned it to the origin, and then we adjusted its height and width and everything, depth, and this will act as the surface of the table right here. And as you can see, we beveled its edges so that it looks smooth from the side, and after elevating it to a specific height, we created the leg, and for this we also used another polygon cube, and we attached it to the bottom of the table, and we also aligned it to the origin so that when we duplicate it, it becomes easier for us. And once we shifted it to the leg to one of a corner, we beveled its edges, and we made the bottom of the leg narrower by using the scale tool, and we then duplicated it to the sides. After that, we also created the supporting beams of the table, like these one, and we also created this using a polygon cube, and we adjusted its height and width accordingly and dragged them to the position we required with the help of using move tool, and we adjusted its height and width with the help of a scale tool. So as you can see, this will be our surface, this will be our table, and we mainly use the polygon cube for it. Now to create the chair, we also used a polygon cube, and we created its legs first, and we aligned it to the origin and made the heights, my height and width according to our requirement, and then we duplicate one to the opposite side. So these are like the front legs of the chair, and on the back legs, as we can see, they are a little bit tilted like this. So for this we inserted an edge inside those, and using the mesh tool functions, in the insert edge loop function, and after inserting the edge in there, we to create the legs, we inserted an edge loop function inside it, so that we can make its back leg a little bit tilted. So after inserting an edge inside, we drag the leg from the bottom using the move tool, so that's why it is tilted. Now to increase the height of the back leg, we use the extrude function on the right here on the top surface, and extrude it and also make it tilted so that its back should be like this. And then we duplicate the leg just by Control D to the opposite side. Since it's aligned to the origin, so it's very easy for us to duplicate by just changing the values of the axis. Now, we also created these frames of the table, and for this we also used a polygon cube, and this was also done by using the scale tool, and we adjusted its height and width accordingly, and we placed them right between the legs, so that it's easier for us. And we only made one, and the rest of the rest three were duplicated. And this is the benefit of aligning everything to the origin, as you can see in this figure. And once you align it to the origin, it becomes very easy for us to duplicate. And now for this sporting frame, we also used an polygon cube, and we made it to our requirement. We increased its length to our requirement, and make it little bit tilted by using the rotate tool, and we fitted it on the top of the chair according to our requirement. And this can be better done in wireframe mode, so it's easier for us to see where it's being placed. And the rest of these back sporting frame were also created like this. Now to create the seating frame of the table, we used a polygon cube, and we adjusted it according to our requirements, and we increased the subdivision widths and heights of the seating frame, so that we can work on its side. As you can see, there are a lot of subdivision heights, and the value of subdivision heights and subdivision width is a little bit high, because we want to work on the side, and this can be done by using the soft tool on the right here. So this is basically actually how we created our 3D model, and this is the final view of our model. Thank you.